Well, good morning. This is the next step in the 435B performance testing. What I want to do today is to check the range accuracy. Now, to do that, I'll be utilizing a range calibrator, an 11683A, which basically is a very accurate voltage divider, power source, and the back part of an 8482A sensor that has the FETs in it and so on. So for all intents and purposes, it looks to the 435B as though it is a sensor with a very specific voltage being fed in that matches what a 1 milliwatt or whatever the range is set to RF power coming into the thermistor head, or the thermocouple head, sorry. So with that, what we need to do, the first step is to get a full range deflection and then adjust the meter so that we're reading on the 34401A 1 volt plus or minus 2 millivolts. So basically there's a recorder output on the back of these meters that is 0 to 1 volt for 0 to full scale deflection of the meter that is in the unit. So have it set up for 1 and 1. So let's turn on the calibrate here. And we can see that we're 9 millivolts high. So let's just go onto the cal adjust here. And we'll just scroll that down. Let's see, we can get a little closer than that, I think. Let's keep going. There we go. So now, with our full scale deflection, we're reading on 1 milliwatt. We're reading 1 volt there. So now we start at the lowest value and then move all our way back up. So let's turn that off. Let's set down to here and set down the range there. The drink of choice today is a coffee from my Keurig, my Seahawks mug. Okay. Now, what I also have is I have a program that I've written that will that will basically do all the recording for us. It'll pull the values out of here. And that way we can just simply go through the process. We don't need to write things down. So let me go in. We'll select instrument accuracy. And let's set that. We'll make sure that we're zeroed here. Okay, let's turn that on. And there we go. And we're being prompted to be fully counterclockwise, which we are. All right, let's go start taking some readings. Okay, and there we go, we're finished, and we can open up our report now. So let's go do that. And if we take a quick look at the report, we can see that we have passed through all of the steps. So our instrument accuracy, according to our 11683A, shows that the power meter is reading correctly. Ah, well, there you go. We're all in the green, so that this guy is all range tested. There isn't a performance test for the meter without having the range calibrator. There is an adjustment process that you can do to adjust the power meter if you only have the sensor and not the range calibrator. So I would assume that what they're saying there is that while we can test with this, you could just go straight and do an adjustment with the output power reference, and then adjust the meter to show the correct value, and then that would be sort of good enough to say that the ranges are correct. I don't believe that would be true. I think the range calibrator is worth the process. There was a project, somebody I think was either on the EV blog forum or on the HPAC group, of somebody building one of these as a completely new unit, and either not utilizing a sensor body or just buying one of the many blown sensors that are on eBay and utilizing that. If you don't have, these are starting to get rare. If you don't have one of these, you can go have a look at that project. Anyway, the next test will be to have a look at the calibration factor, and it's a similar process. We'll set a 1 milliwatt full-scale reference, and then we measure the recorder output as we vary the calibration factor back down, and as that gets smaller, the voltage will get larger because of the factor that's been set, and so we'll just continually measure that until we get through all 16 steps, I think there is. Anyway, I hope you found that interesting, and I'll see you again in the next video. Catch you later.